Redox stands for reduction and oxidation. A reduction is when the oxidation number of a species is reduced during the course of a reaction. An oxidation is when the oxidation number is increased during a reaction. You cannot have one without the other. If something in the reaction is being reduced, something else must be being oxidized. Hence why this is called redox. You've got to have both the reduction and the oxidation. Let me give you an example. Oxidation number is essentially a bookkeeping way to keep track of where the electrons are. If you're talking about an element or an ion, the oxidation number is equal to the charge. So here, Cu2 plus is going to Cu neutral. The 2 is being reduced to a 0. So that is a reduction. In this reaction here, Fe2 plus is becoming Fe3 plus. So this is an oxidation. The 2 is going up to a 3. If both of these are happening at the same time, here is my redox reaction. Cu2 plus Fe2 plus goes to Cu plus Fe3 plus. You'll notice these 2's here. There can't be any leftover electrons in the equation. So if 2 electrons are being added to the Cu2 plus to get Cu, those 2 electrons have to be coming from the Fe2 plus losing an electron to become an Fe3 plus. That has to happen twice so that there are 2 electrons for the copper. So this is balanced. You'll notice not only are species balanced, but the charges are balanced. There's a 6 plus on both sides. A lot of times a redox can just be balanced like a regular equation. As long as your charges are balanced and your species are balanced, it's balanced. Sometimes you have to worry about whether it's in an acid environment or a base environment. And that's because you have to use either H pluses in the case of an acid environment or OH minuses in the case of a base environment to balance charges. So for example, let's work with half reactions now, that is only the reduction or the oxidation, just to make life easier. Let's say I have MnO4 minus going to Mn2 plus, which is a very common redox reaction. If you see MnO4 minus, immediately think redox. You'll notice, by the way, this is net ionic. There's some other spectator ions that aren't written here. Now the Mn is the thing that's being reduced here. We don't have to worry about the oxygen at all. Let's just think about the Mn. The oxidation number of this guy is 2 plus because it's the same as the charge. I know oxygen is always a minus 2. Minus 2 times 4 is minus 8. That's a plus 7. So don't worry about this charge. What we care about is the oxidation number. 7 is being reduced to a 2. First, we have to put in electrons. 7 minus 5 equals 2. That part is balanced, and we know it's a reduction. The problem comes when we're trying to balance charges. I've got 6 negatives on this side and 2 pluses on this side. So if I'm in an acid environment, I know I've got a plethora of H pluses, because that's what acid is. So adding 8 H pluses here balances the charges. 6 negatives plus 8 pluses gives me 2 pluses, which equals that 2 pluses. Charges are balanced. Now remember that oxygen I've been ignoring all this time. I've got a balanced species when I balance equations, so I need oxygens over on this side. Well, if I'm in acid, I'm also in an aqueous solution, so I've got a plethora of waters. So I'm just going to add 4 waters here, and that works. 8 H's, 4 oxygens, 1 Mn. Charges are balanced. That's a balanced half reaction. Then I would just have to balance the other half and add them back together. We're making sure the electrons cancel, just like in that copper iron one on the other page. If I am in base, it's exactly the same thing, except instead of H pluses, on the left side, I'm going to have to add OH minuses on the right side. And then the waters are going to end up on the left. Pause the video for a moment and see if you can figure out how many OH minuses to add. Okay, I hope you paused and figured it out. Let's see. Once again, I've still got 6 negatives here and 2 pluses here. So 8 OH minuses here gives me 6 negatives to balance the 6 negatives. And then 4 waters will balance with 8 hydrogens and 8 oxygens. So this is the half reaction in acid. This red one is the half reaction in base. So those are the only things you have to remember. You have to remember to balance oxidation number with electrons. Then you have to remember, if necessary, and it's not always necessary, to balance charge with either H pluses or OH minuses. And then, if necessary, you have to add water to balance H's and O's.